Hey everybody, welcome to the Unit 5 or the Chapter 4 review. This review is kind of lengthy, so to attempt to cut it down on time, I have everything solved out ahead of time, and I'm just going to explain to you my thought process behind doing it. So at the top of the paper, I wrote this note. If the graph does not show an intersection, then you'll need to solve it by hand using completing the square or quadratic formula. So the first 4 problems are all solving problems. And so you can type those into the graphing calculator to get the answer if there's an intersection. If there's not, that's where we're going to use completing the square or quadratic formula. So in this first one, I have it typed in, I have x squared plus 4x typed into line 1 and y equals negative 5 typed into line 2. You can type this in all on one line, and if there's no solution, it'll just be blank. You can keep zooming out. I recommend if you don't see anything, you zoom out because sometimes the graph just is higher up or lower down than the default window. But yeah, if you keep zooming out, there'll be nothing there. But what I kind of prefer doing is typing in the left side into line 1 and the right side into line 2. And then for some reason, if you just type in a single number into line 2, it won't work until you type in y equals. So just keep that in mind. But yeah, here you can clearly see the two sides are not touching. So my answer is going to be an imaginary solution or a complex number as it's known. So I'm going to solve this one by completing the square. So what I have here is the original written in black, and the first step to completing the square is adding in your b over 2 squared term to both sides. So my b term here is 4. So 4, I'm going to add in 4 over 2 squared to both sides. 4 over 2 is 2, 2 squared is 4, so I'm adding in a 4 to both sides. What you do on the left side is you factor it. This is now a perfect square trinomial, meaning the factors of the last number that add up to the middle number happen to be the square root of the last number. The square root of 4 is 2, and if you use plus 2 and plus 2, you'd equal plus 4. So the factors of 4 that add up to 4 2 and 2, positive 2 and positive 2. So you have x plus 2 times x plus 2, or since it's saying the same thing twice, x plus 2 squared equals negative 5 plus 4 is negative 1. So the next step is to now square root both sides. So the square root of negative 1 by definition is I. Just don't forget to put your plus or minus symbol there. Every time you do a square root, you got to use the plus or minus sign. And then square rooting this just leaves behind the x plus 2. So all I have to do now is just minus 2 to the other side and put that negative 2 in front because it can't combine with the I. It's not going to make negative 2i or anything like that. It'll just make negative 2 plus or minus I for the final answer. On the second example here, you'll see that I graphed the left side into line 1, the right side into line 2, and I'm looking for the intersection, but there is none. So once again, I'll have to solve this by hand because there's going to be an imaginary number or complex solution. So in this one, I'm going to use the quadratic formula. To use the quadratic formula, everything needs to be on one side. In other words, the equation has to be in standard form. So ax squared plus bx plus c equals 0. So what I did was I took this negative 10 and I plussed it over, and I took this 4x and I minused it over, and everything will be on the same side. None of these terms combine. 10x squared can't combine with negative 4x because it doesn't have the power of 2, and it can't combine with a 10. So you have 3 separate terms. 10x squared minus 4x plus 10 equals 0. Now everything's in standard form. You'll be able to determine your a, b, and c. So my a is 10, my b is negative 4, and my c is 10. Plug all that into your quadratic formula. What I did was I simplified the inside of my radical. That's called your discriminant. And so make sure you use parentheses whenever you're plugging in these numbers, because especially if you have negative numbers and you don't use parentheses, you might get it wrong. So the negative 4 squared minus 4 times 10 ends up making negative 384. If you are not sure if a number is a perfect square or not, just take the negative out and type it into a calculator. The square root of positive 384 is like 19 something. So if you get any number with a decimal, it's not a perfect square. So you got to break it down. What are your perfect squares? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, so on. So 8 squared is 64. And if you do 384 divided by 64, you get 6. So I'm able to simplify this discriminant right here by splitting up negative 384 into two factors, negative 64 times 6. The square root of negative 64 would be plus or minus 8i, because the square root of 64 is just plus or minus 8. And then the square root of 6 would stay behind. So I just wrote this plus or minus 8i square root 6 in place of the square root of negative 384. And so at this point, you want to see if you can simplify your fraction. Can 4 and 8 simplify by dividing it by 20? And yes, they can. All three of those numbers are divisible by 4. So 4 over 20 makes 1 over 5, and 8 over 20 makes 2 over 5. So my final answer here is 1 plus or minus 2i square root 6. On example 3 here, if you type it in all on one line, you'll see you have two vertical lines. That's good news. That means those are going to be your solutions. And but if you type it in my preferred way, you can see the quadratic side intersecting with the linear side. And either way, you get the same answer. You're just looking at the x coordinates. Once again, if it equals a single number, just put a y equals in front when you're graphing it. Now your answer choices might have a square root in them rather than writing these. So the square root of 2 is approximately 1.414. And so, if you have these decimal answers and your answer choices are not decimal answers, then just type in the square root into a calculator. And so in this case, I'm typing in the square root of 2, and you'll see that it equals approximately the same thing as these. All right, so that's pretty much all there is to it. But yeah, this one I didn't have to do anything by hand because there are intersections. Number 4 says solve the equation x squared minus 8x plus 17 equals 0 for all complex numbers. If it says it has complex numbers, then you can kind of skip the graphing part because complex numbers mean that there are going to be no real solutions. You're going to have imaginary solutions. But I went ahead and I graphed it anyway. Whenever it equals 0, you don't have to type in the equals 0 because that's just going to make the x-axis. But I went ahead and I typed in y equals 0, and it kind of highlights it, which is nice. But you can see that the parabola is not intersecting at all with the x-axis. So I'm going to use a quadratic formula. You could use completing the square if you like that better, but I'm just going to stick with quadratic formula for this example. So here's my quadratic formula again. You just need to make sure that everything's in standard form so you can identify your a, b, and c to plug those numbers in. Everything is in standard form because it equals 0. So I have a as 1. I have 1x squared there, minus 8x, so b is negative 8, plus 17, that's my c value. Plug all those numbers into your quadratic formula and simplify your discriminant. Negative 8 squared is 64, minus 4 times 1 times 17, that's 68. So 64 minus 68 is negative 4. So the square root of 4, that's a perfect square. That's plus or minus 2. So the square root of negative 4 would be plus or minus 2i. So I just took the square root of negative 4, turned it into a 2i. And so are 8 and 2i divisible by 2? Yes, they are. 8 divided by 2 is 4. 2i divided by 2 would just give you 1i, so you can just write I. So I have my final answer here being 4 plus or minus I. So for number 5, it says, which of the following systems best represents this graph? If you can't identify, the attributes from the equations, then what you'll want to do is you'll want to type it into your graphing calculator, and you'll have to test each answer choice. Fortunately for me, it ended up being A, so I only had to test one of them. But the strategy here is to look for points that are easily identifiable. Okay, so looking at this graph, the only thing I can tell that it's going from 10 to negative 10 on both axes, but there's no grid here, so it's hard to tell where all the values are. But you can tell where the x-intercepts are at 2 and negative 2, and then it happens to intersect with the linear equation at the negative 2 x-intercept. I can see the linear equation goes through negative 2 in the y-axis here. The quadratic goes through negative 4 there. And this point looks like it's at 1, negative 3. So when I graph my answer choices, I wrote this note. I basically just said everything. I just said all that to you, though. When I graph my answer choices, I'll look for those things. Here are the x-intercepts at 2 and negative 2, and look, they intersect there. I have a y-intercept at negative 2 and another one at negative 4. And then, yeah, they do intersect at 1, -3 in this answer choice. So all these other points were the same, so I can gather that 1, -3 was a good estimation. So yeah, that's why number 5 is A. That's pretty much it. Just look for points that are easily identifiable, such as x-intercepts or y-intercepts or points of intersections. Number 6 is asking for the solution to these two equations. So really you just have to graph them. You can solve it by hand using substitution or whatever, but all you have to do is just type in y equals -x squared plus 1, y equals -2x plus 2, and you see they intersect once at 1, 0, making that my answer. Number 7 says, how many real solutions does the system below have, and what are they? Well, all you got to do is just graph them, and you'll see that there are no solutions. So there's no intersection, so how many? 0. What are they? It's just no solution. You don't have to calculate for imaginary solutions when it says there's a system of equations, okay? Whenever it's just a quadratic equation, like a singular quadratic equation, then you have to calculate for complex numbers or the imaginary solutions. But when there's a system of equations, it's either one intersection or two intersection, identify those, and those would be your answers. Or there's no intersection, so the answer is no solution. So number 8 looks like it'll be a tricky question, but it's actually very simple. It says, if f of x equals x squared minus 12x plus 46 were put into vertex form, y equals a times x minus h squared plus k, then where's the axis of symmetry? So if you were to actually convert this into vertex form, you'd have to complete the square and do all that work. And then the number on the inside tells you your vertex. So if it said x minus 2, your axis of symmetry, I said vertex, I meant to say axis of symmetry. So if it said x minus 2, you would say x equals 2 for your axis of symmetry. If it said x plus 4, you'd say x equals -4 for your axis of symmetry. You don't have to do all that because you have an equation here that you can graph. And as long as you know that the axis of symmetry is the x-coordinate of the vertex, and then the y-coordinate would stand for the min or max value. I just thought I'd point that out in case that comes up on the test. But as long as you know that x value is the axis of symmetry, then you're good. So I just graphed the original equation. I looked at the vertex, and your axis of symmetry runs through the vertex, so it's x equals the x-coordinate, which is 6. So that's why I wrote down x equals 6. Okay, so I didn't have to do any conversion there. Number 9 is asking for the positive solution. I've witnessed kids in the past answer a question like this incorrectly. They graphed it. They see there's one positive and one negative, and for some reason they put down the negative solution. So just make sure you read it carefully. Again, if it equals 0, you don't have to type in the equals 0 because you're just looking for where it equals or where it touches the x-axis. So -3 would be the negative solution, and 7 would be the positive solution, which is the one I'm looking for. Again, if you type it in all on one line with the equals 0, you'll get these vertical lines where your solutions are going to be. And then, like I said, I just highlighted 7, 0 because x equals 7 is the only positive solution. So my last two examples here are going to be quadratic motion graphs. You don't have to memorize the formula because you can go back and check the notes, but just remember the quadratic motion formula starts with the -16x squared, and then it's plus initial velocity x plus your initial height. So if I were to read this problem to you, it says a software developer from Minecraft makes a player jump from a building 10 inches off the ground with an initial velocity of 30 inches per second. An Enderman can propel himself towards the player along the linear path shown. Write a system of equations to represent this situation. Okay, so I highlighted that the building is 10 inches off the ground. That's your initial height. And then it says your initial velocity is 30 inches per second. So I'm going to plug in 30 for the V naught and 10 for the H naught. And so this is my quadratic motion equation. All right. To identify the linear equation, you just got to remember that y equals mx plus b. M is your slope, your pattern, your rise over your run. And your slope formula is y2 minus y1 over x2 minus x1. But sometimes you can figure out the slope without actually having to do that work. And then b is your y-intercept, meaning what's the y coordinates where it intersects with the y-axis, I guess. Yeah. So this is at 0, 0, so my b is 0. And then what's my slope? What's the rise over the run? Well, it went from 0, 0 to 3 to 1 comma 3. So it rose 3 and it ran 1. So 3 over 1 is just 3. So my slope is 3. Okay? But, if that's not coming to you, then, pick 2 points. You can use the first 2 points, or I can see that this one goes through 2, 6, so I use these two. y2 minus y1 would be 6 over 3. x2 minus x1 would be 2 minus 1. I said 6 over 3. I should have said 6 minus 3. But yeah, you get m equals 3, so you get y equals 3x. So there are your 2 equations. You can always graph them to make sure they pass through the points that are easily identifiable here, to see if they match as well if you want to go that route. So for my last example, I have the graph shows the height, y, and feet of a soccer ball x seconds after it is kicked from the base of a hill with an initial velocity of 20 feet per second. The linear function represents a hill with a constant slope. Write the equations that model this situation. At what time will the ball land on the hill? What is the height of the hill at the point of contact? Okay, so I highlighted that the initial velocity is 20 feet per second, so v naught is 20. And then it says that the ball's kicked from the base of the hill, so my initial height must be 0, so h naught is 0. So I just plug in 20 and 0 into the formula. Since it's plus 0, you don't actually have to write it. So I have y equals negative 16x squared plus 20x for the quadratic motion. I'm going to look at the slope of the line. And so it goes from 0, 0 to 0.5, comma 1 to 1, comma 2. So if you just kind of skip over this point, it's going from 0, 0 to 1, 2. What's the rise over the run? The rise was 2. The run was 1. 2 over 1 simplifies to get 2. So my slope must be 2. All right? My y-intercept is 0. So y equals 2x must be my equation. And so I have, and then I showed my work here, but like I said, you can kind of do that one in your head. But if you pick 2 points, you'll end up getting m is 2, and then that y-intercept is easily identifiable at 0. So these are my 2 equations, negative 16x squared and plus 20x, and y equals 2x. And so you can kind of estimate where the answer will be here, but to get the exact answer, you'll want to graph it and look at the point of intersection. And just remember, x is time, y is the height. So the ball was in the air for 1.125 seconds, and then it landed on the hill 2.25 feet up from the base of it, I guess. So with that being said, that's going to close out these review examples. Thank you for watching. Good luck on your test, and goodbye.